This is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a topic called as fundamental of stereoscopy. So this fundamental of stereoscopy, this stereoscopy is used in aerial photographs. Usually we use stereo pairs for determining the height of the object. So we need a stereo pair of photos which we get it from the flight line direction in the same direction. When a flight goes in the same direction, it keeps on clicking the images. So overlapping area of the images, we call it as stereo image, and it should be from the same flight line. So that we are going to discuss, and that is going to help us to find out the different height of the different objects in a different places. So let us discuss about this fundamental of stereoscopy. So what is stereoscopy? So stereoscopy, first of all, we should understand what is stereoscopy. So stereoscopy, it is usually called as stereoscopic imaging. It is a technique which enables us for a three-dimensional effect, adding an illusion of depth to a flat image. So it's like two images we take in a series of aerial flight line, like photo 1 and photo 2, and it should be from same flight line, and we just combine it together and try to find out the height of the object, 3D vision of the object, whatever object we see in an overlapping area. With the help of a stereo pair, we are able to get the 3D depth or three-dimensional effect. So in aerial photography, when two photographs overlap, so I hope we have discussed in the previous lecture what is overlap. So overlap is an area with the same flight line direction. Suppose this is the flight line direction. When it goes from this direction to here, or this direction to here, like it goes to west to east or east to west, what happens in a direction, it keeps on clicking the photo. Photo 1, photo 2, photo 3, photo 4, photo 5, photo 6, photo 7, photo 8. Like that, in a direction, it keeps on clicking the photo. And finally, what happens while in a forward direction, this is a forward direction of the aerial photo, forward direction. What happens here, we have some overlapping area. Like overlapping is nothing but it's a common area in photo number 1 and photo number 2. So photo number 2 and photo number 3, there will be a common area. This is called as overlap. And this is always known as forward overlap. Forward overlap. So this forward overlap is usually we are able to receive in this kind of flight line direction when it goes from west to east or east to west. So when it goes from east to west, again, what happens? It clicks the photo 1, photo 2. So we'll be having some overlap area in the first flight line and the second flight line. So this overlap area, we call it as end lap, and this overlap area, we call it as forward overlap. So these two kind of overlaps we generally use for the stereoscopy. And when two photographs overlap on the same ground area is photographed from two separate positions, forms a stereo pair. So it forms a stereo pair used for three-dimensional viewing. Okay. So thus obtained a pair of stereoscopic photographs or images can be viewed stereoscopically to determine the parallax. So parallax is very important to determine the height of the object. When we have a pair of stereo pair, like stereo photos, like we generally call a stereo pair of photo, like photo number 1 and photo number 2, that we call as stereo pairs. With the help of that stereo pair, we are able to determine the height of the object. That is called as parallax. Parallax is like it's like observation. The point of observation will be different for each photo of the same object. So that's how we just determine. So here we have a stereoscope again. So till now, whatever we were discussing about the stereo photos or stereo pairs or stereoscopy. So this is an instrument. This is an instrument which we use it to find out the 3D illusion. Right. So this is the instrument, we use it in the laboratories, and here we take it two photographs. These are the two photo 1 and photo 1 and photo 2. So in this two photo, we'll be having some portion of the area will be overlap. Like this portion or this portion will be common. This portion and this portion will be common. When we just keep it on the each other, this portion and this portion will be common of the photo, and we try to see the 3D illusion. When you keep these two photos together, so due to the stereo vision, this is stereoscope, when we see with this two lens, we are able to just find the 3D vision in the image. So here just overlap, here we can see the overlap aerial photographs, just now what we were discussing here. So here you see this is the flight line direction. The previous slide we have discussed. This is the flight line direction. So here we have an exposure station, and here we have exposure station. So when the flight goes in this direction. So photo number 1 is this. So this is one photo, and this is the second photo, and this is the third photo, right? So photo 1, photo 2, photo 3, right? So photo 1, photo 2, photo 3. So in this 3 photos, we have this portion as a overlap, this portion as a overlap, and here we have a overlap. So this overlap photo, photo 1 and photo 2, if we take it together, these two photos are called as stereo pairs, or else we call it as overlap photos. And these two photos only we can use it for the 3D vision, or we can just use it for the determination of the height of the object with the help of the parallax. Now stereo pair image. So what is it generally, till now what we were discussing, that stereo pair like in photo 1 and photo 2. So this is the actual real image. This is the real image of an area. So stereo pair image contains two views of a scene side by side. One of the view is intended for the left eye and the other for the right eye. So these images sometimes viewed with special equipment to direct each eye onto its intended target, but they are also often viewed without the equipment. So this is photo 1 and this is photo 2. So these are of the same flight line direction. Now you observe one thing here. In this photo, this building appears here. You can see this building is appearing here. While in this photo, slightly this building is somewhat shifted to this position. Okay. And here you can see this portion area is covered and this portion covered. So here you can see around 50% covered. Here only 30% covered. Now you can see this junction. So in this photo we can see this is the road and this is the junction here. Now it is covered only half of the junction in this photo, whereas here you can see this is the junction, this is the road, this is the road. So here a half portion we can see here around 80% it is covered, right? So this is the image. So when the flight is moving, you can just say the flight direction is going from east to west. This is the flight line. This is the flight line. This is the flight line. Here flight has clicked a photo. So in this photo you can see this portion. While clicking the photo, only this much 50% area was covered for this junction. Now again it has moved forward. Now it has covered this total 80% area of this junction. So here you can see this portion from here to here and this portion from here to here. So this is the common. So this is the overlap portion. Okay, this is the overlap portion in this image and this image. You can see only the difference is this junction you can see here 50% and this junction you can see here 80%. Okay, but whereas if you see in these images, this building, this building, this building, this building, and this all area, it is commonly visible in both the photos. So when we keep these two photos side by side, so this is from the same flight line we have taken. So if we keep these two photos side by side, and if you keep the stereo pair, which I was showing you before, if you keep the stereoscope over that image, when you combine these two images, our eyes can see a illusion called as 3D illusion. It will show you the 3D, the elevations it will show you. When you keep these two photos, this is called as stereoscopy. So stereo illusion will see with the help of the one pair of stereo photo. One pair of stereo photo should be from the same flight line. So in that, it should be sure that the overlap area should be 60%, more than 60%, 70% to 80%. So this overlap area, if it is there, then only we are able to see the stereo vision. Stereo means 3D vision. Okay. Now, if you see this orientation of stereo pairs, how generally it occurs. So here, orientation of stereo pairs. How stepwise it is shown here. Obtain two photographs consecutively marked on a flight line. So this is the photo number 1. This is the photo 2. So photo 1, photo 2. So photo 1, photo 2 we have here. Now if you observe this line and this line. So here in this photo 1, this is appearing in the right hand side. This sign is appearing in the right hand side. Whereas the flight line direction is like this. So photo 1 it has taken. So in this position is here. Now again when it moves to this position, when it clicks on the photo, now you can see this in this photo number 2, it appears somewhat here. So this portion will be common in photo 1 and photo 2. So when we keep it side by side, we will get to know the overlapping area, and we are able to find out the 3D illusion, like elevations we can see in this image. So locate and mark the principal points on each photograph. So this is the principal point of this photo, and here is the principal point of this photo. You can just see that principal point of photo number 1 is here somewhere, and in this photo number 2 is somewhat here. So in this photo you can see the difference, this portion and this portion. You see here more portion is covered, here less portion is covered. So locate and mark the conjugate principal points on each photograph. Line up all 4 points and adjust the distance between photographs to suit your needs. Next, fundamental of stereoscopy. So in the stereoscopy, now same two images we have taken of the same flight line direction. Now you observe one thing here. In this photo 1, this is the river, what you can see. So almost all portion of this river in this photo is visible. Whereas in this photo, you can see few portion of the river is visible in this. So this area from here to here, here to here, and from here to here is common in both the photos, right? Now, it is a technique used to create or enhance the illusion of depth in an image by presenting two offset images separately to left and right eye of the viewers. This creates a three-dimensional effect when the brain combines the images. So that means when you see from your left eye, when we see from your right eye, so we can see two different images, separate images. Whenever you see an image from your left eye, and when we close your right eye and you see from the left eye, you can see a different image. When you close your left eye, when you see your right eye, you can see a different image. But our eyes are like, when you see together, it combines the image and it will show you a 3D image. So this 3D effect, when the brain combines the images, we can see. So stereoscopy is commonly used in various fields, including entertainment, 3D movies, virtual reality, medical imaging, and industrial applications. So widely it is applicable in various fields. Like we generally use in movie, 3D movies generally we see. And in medical imaging also it is widely applicable, and it is applicable in industrial applications also. Now, aerial photogrammetry is a technique. Aerial photogrammetry is a technique that uses photographs taken from elevated position, and usually it is taken from the drone or aircraft, and it creates the accurate 3D models, and it is usually used to create the accurate 3D models of the Earth's surface on the objects. And the process involves capturing overlapping images, and through the analysis of these images, the software can determine the spatial relationship between points in the images. So this process involves, for a stereoscopy, this process involves the capturing of overlapping images through the analysis of these images, and the software can determine the spatial relationship between points in the images. Now, if you see, stereoscopy is also called as stereoscopic or stereo imaging. So, stereoscopic, why we call it as, we use a stereoscope. We use a stereoscope, or we call it as stereo imaging also. Stereo imaging is what? Stereo imaging is, stereo means one pair of, one series of photo, one pair of stereo pair means where we can see overlapping areas. That's why we use it as stereoscope, and is a technique for creating or enhancing illusion of the depth. And it is a technique for creating illusion of the depth in the image by means of stereo. And it is for binocular vision. It is for the binocular vision. And the word stereoscopy derives, and usually it is derived from the Greek stereos, known as firm and solid, and it looks to see. Any stereoscopic image is also called as stereo. Stereoscopy is also known as stereo vision, and is the process by which depth perception is created. Depth perception is created means we can see the 3D vision where you can see the depth, like you can see the elevations of the objects, and you can finally see the depth of the objects. And the brain, when it receives slightly different images from the each eye. So there are some simplified simplified explanation of how stereoscopy works. So we have different types of ways how the stereoscopy generally it works. So when you talk about the binocular vision, human have two eyes, as we have discussed before also. Human has two eyes, and each position slightly apart on their faces. So each eye captures a slightly different view, and the world because of the distance between them. So here in this picture, you can see this is the left eye and the right eye you have. So from the left eye and from right eye, we are going to see the stereoscopic model. So this is your building where we can see. So when we see from the left eye, we can see this side. When we see from the right eye, we can see this side. But once you combine these two images together, when you see from both the eyes, it will combine the image and it will show you the 3D vision. So it's a pseudo stereoscopic model where we can see the use of binocular vision to achieve three-dimensional effects enables you to view an object from two different camera positions to obtain a three-dimensional view. So stereo pairs of photography. Two adjacent overlapping photographs in the same flight length. Stereo views can only be seen in the overlapping portion of the photos. So as I said, stereo pair, when we take a stereo pair, stereo view if you want to see, that means if you want to see the 3D vision, if you want to see the 3D illusion or binocular vision or something like depth perception, then only we need a photo is called as overlapping photo. And that too we can see the 3D in the overlapping portion itself. We can't see the other image. Now this is the binocular vision, like seeing in 3D. So the brain uses several tricks to make us see three dimensions. Despite our almost 180-degree field of view, binocular vision is only possible in the area where view from both the eyes overlap. So this is our view will be if from the both, this is the right eye and we have the left eye. So our view from the both the eye, it is for the 140 degrees field of binocular vision. So this is what it combines the image together and it shows us the object in a single 3D view. So in an object is nearby, the brain can judge distance, how converged or crossed your eyes are. So stereoscopy versus normal image. When you see this is in a normal image, both of our eyes sees the same picture. Like this is the normal image. When you take a single image, normal image, so if you see from your left eye, it will be somewhat different. From right eye, it will be somewhat different. And but usually it will look like this. But in a stereoscopic image, our two eyes sees two slightly different images, and that's how illusion of three-dimensional depth is created. Now, in a stereoscopic image, this is photo 1, this is photo 2. So always remember, stereoscopic image in a stereo pair, we have to take from the same flight line direction, and that too from a same flight line series, photo 1 and photo 2. We cannot take photo 1 and photo 3. We have to take photo number 1 and 2. So if you are going to take photo number 2, definitely we have to take the photo number 3. So if you are going to take photo number 4, either you have to take the photo number 3, either we have to take the photo number 5. Then only we are able to see the stereo vision. Otherwise, we are unable to see the stereoscopic vision. So it should be from the same series, same direction, same flight line direction. Then only we are able to see. Either the flight line direction should be west to east, either the flight line direction should be east to west. Okay. So, but a stereoscopic image, our two eyes sees two slightly different images, and that's how illusion of three-dimensional depth is created. So this is photo 1 and photo 2. So it is seen from two slightly different images are there, and our two eyes will see two slightly different images. That's how the illusion creates. So this is the overlapping area in the both the images. So it will show you the illusion when you keep these two photos side by side, and when you see from your binocular vision or something like if you use a stereoscope, you keep on this photo, then we are able to see the 3D illusion. We are able to see the 3D. So like when you wear a 3D glasses, then also as we have discussed, it is used in the movies also. So when you use a 3D glasses, we are able to see the image in the television in a 3D view. So this is how our eyes are able to see the 3D vision. Now second thing, what the second way, first way was binocular vision, and second way is of stereoscopy is image parallax. So what is a parallax? So parallax is a very important thing for studying or for determining the height of the object. So we can even just find out the height of the object with the help of the stereoscopic parallax. So stereoscopic parallax is like taking the same one pair of photos with the same flight length. So again, this photo 1 and this is photo 2. So this is of the same series, photo 1 and photo 2 of the same series. Now you just observe here, we have this photo 1 and photo 2. Now in this, if you just see this displacement here. So if you remember in the previous lecture, we have discussed about the relief displacement. So here we have a relief displacement again. So relief displacement means different when the flight line direction goes in a direction, you will be finding that the image in an image, a building or an object will be displaced a little bit. Like in this image, you can see the top of the or this side, little side view we can see. But whereas in this image, you see this tower is visible from here to here, right? Here to here. Base is visible and this much portion is visible. So this much portion is displaced in this photo and this much portion is displaced in this photo. So with the help of this displacement, there is a formula with the help of that we'll be discussing in the coming lectures, that there is a formula with the help of this displacement, we are able to find out the actual height of this object. So when we keep these two images side by side and we use a stereoscope to just find out the 3D view, we can just with the help of the stereoscope, with the help of the stereo lens, we are able to just see the elevations of this all objects. So we can see the 3D view of all the object with these two overlapping photos. So overlapping here, where is the overlapping here is, we can see here this portion is common and this portion is common in the image. So with the help of these common overlapping area, we are able to find the elevation. So what is a parallax? Image parallax? When you look at an object, your brain combines the image from both eyes and interprets the differences between them. Objects that are closer to you appear to shift more between two images, while distinct objects appear to shift less. So when you see your brain combines the images from both eyes and interprets the differences between them. Objects which are closer to you, it always appear to shift more between the two images, while distant objects appear to shift less. So more the closer object, it appear to shift more, but while the distant object, you appear to shift less. So image parallax is usually it's a point of observation will be always different. So this point of observation in this image is somewhat here. So the image is clicked from somewhat here, and this image is clicked from somewhat here. So the point of observation is like this. Here the point of observation is like this. So that's how the image will be overlapped, but the objects in the image will be displaced a little bit due to the change of position of the position. Now you have a depth perception. The depth perception is like when you see a 3D image, you will be seeing when this ball is there, you can see this is a 3D view, but you can see this ball is falling in a depth, right? You can see there is a depth here, but actually not. It's an illusion. Again, it's an illusion. So based on this depth perception, by comparing the disparities between the images received by each eye, your brain is able to estimate the distance to the object in the scene. This process is known as depth perception. It allows you to perceive the world in 3 dimensions. So these are the different 3 ways how we can just get to know about the stereoscopy. Now we have types of stereoscopes. Types of stereoscopes means we generally use the stereoscopes for the stereo vision. Like in this we have, if in stereoscopy the principle is replicated artificially and using the images or video. So two slightly different images of the same scene known as stereo pairs. So slightly different images of the same scene. Slightly difference of the same scene means if you see in this, these are from the same scene, but there is a slight difference how we can identify. You see this tower is slightly displaced. So slight different, but two different images we'll see will be known as stereo pairs as presented separately to each other. So when viewed through a stereoscope or special glasses with different filters for each eye, the brain combines and the images of and perceives depth in the resulting 3D or video. Now, if you talk about the types of stereoscopes, we have different types of stereoscopes. One is mirror stereoscope. So mirror stereoscope will look like this. It has a mirror here and it has a lens over here. So this is used in the labs for finding the, so one image is here, one image is here. So it's like photo 1 and photo 2. So this is used for used in the field. We generally use in the field for just finding the stereo vision. Stereo vision is 3D vision. 3D vision of the overlapping area. Stereoscopy is nothing but it's the 3D vision of the overlapping area. So always remember, when you want to check the 3D vision, we need a pair of stereo pairs. We need a pair of photos which are stereo photos, and that too it should be overlapping photo of the same series of the same pattern and direction. Now scanning, there is a one more type here, scanning mirror stereoscope. What is scanning mirror stereoscope? A series of lenses, prisms, and it is relatively expensive and it is not used in the field. So this is a kind of scanning mirror stereoscope. So you can see this again photo 1, photo 2 is kept here. So this is for the mirror stereoscope. It is also used for the stereo vision, but usually it is not used in the field for the different views. Now we have a zoom stereoscope. So here we have a magnification of 2.5 to 20x, and it's very expensive and it is not used in the field. It's not used in the field. So which one we use it in the field is mirror. Generally we use it as mirror stereoscope. These are used in the laboratories in the field for finding the 3D vision in the image. So for today's lecture, I hope you understood what is stereo pair and what is stereoscopy and what is overlapping photos. So stereoscope is always what to say? Stereoscope is a instrument. With the help of the instrument like this, we use it to view the 3D vision in a overlapping series of stereo pair photos. Okay. So when you have a stereo pair means a pair of photo. A pair of photo means you'll be having two photos of the same series, photo 1 and photo 2, or photo 2 and photo 3, or photo 3 and photo 4, or photo 4 or photo 5. It should be from the same series. And definitely the common area like overlapping area, that is 60% overlap or 50% overlap, is must to determine the 3D illusion. Or finally, we can just find out even the height of the object with the help of this stereo pair of images or stereoscopic parallax. So that's all for today. We have here references from where we can just get to know about the stereoscopy or stereo press. M.N.G. Reddy is the book where we can just find the content, and Fundamentals of Remote Sensing by George Joseph and University Press Hyderabad. We can just find out the content, and these are few of the online references where we can just find out the content about the stereoscope. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.